All right. Hi, guys. So this week you have your quiz, or not quiz, your test, sorry, for your waves, topics of light waves and mirrors and lenses. Some of you have been doing really well. Again, if you rush through any of the material, then you're probably going to end up not doing so hot. Okay, so take your time, take good notes. You're able to use your notes both on your quizzes as well as on your tests, so make sure you're taking good ones. Okay, um, I have um, a quick review. There's a review that comes before the test that you take. You have to actually pass that review before I clear you to take your test, because if you fail the review, then you're gonna fail the test more than likely. So what's the point, right? So make sure that you're completing that review and scoring above that score before I move you on. Okay, so let's go ahead and look at a couple of things and some highlights of stuff that you need to know. So the primary one, when we're looking at light, we're looking at behaviors of the waves, which is reflection versus diffraction. So I'm going over the highlighted stuff. I'm not really going to be going over the basics of like the properties of waves and stuff like that, because it's pretty basic and I have confidence that you'll be able to figure those things out. But I wanted to hit on the things that I think need a little bit more attention. Okay. So reflection, of course, is the law where the incident angle is equal to the reflected angle that bounces off of a surface. So you can see here the incident angle is any ray that goes into or towards something. It's what's coming in. It's the action, an incident of that ray occurring. Reflection, of course, is it bouncing off of something or some kind of surface like a mirror or even glass. It can bounce off of that, anything along those lines. The dotted line here is what we call the normal. Remember, which is just a reference line that's 90 degrees from whatever surface that we're looking at. Same thing as we talked about before. But this angle and this angle are always going to be equal. That's why when you look into the mirror, you see yourself. You don't see something different because the angles are going to be equal. That's when that the incident rays are going towards versus what's coming out. They got to be the same. All right. The other thing is behavior is what we call diffraction. Diffraction is now when you have light that's traveling through one kind of medium and then goes through something in order to be another medium. So there's no bouncing that's happening here, and then it kind of changes the direction, and it almost looks like, when you look at it, it's like what we call bending. If you ever had a straw in a drink and you kind of see how it doesn't look straight and it looks bent, that is diffraction. Okay. So this shows you kind of like, this is the light ray traveling through air, and then it actually goes through a glass and it actually changes its direction because its speed is changing. And its speed is actually going to be slowing down because it's actually going through something that's more dense, that's going to take longer for the particles to travel through. Facts, reflection. The speed for light never changes unless it's going through a medium like you see in diffraction. Otherwise, the speed of light when it's traveling through a vacuum, meaning space, meaning nothing, is always going to be the same, which is 3 times 10 to the 8th meters per second. I think in your Ingenuity it says it's 2.99. You can round it to 3. So 3 times 10 to the 8 meters per second is the speed of light. That is always the speed of light. That never ever changes, no matter what, right? It does bounce in reflection. So bouncing off of things, that is reflection. And then it changes direction. So you can see here, this is going to be moving in a straight line until it hits the surface and bounces, then it changes the direction that it has. It does not pass through any mediums. So reflection is only when it bounces off of a surface. It has never and won't ever talk about going through a medium. That would not be considered reflection. So facts about diffraction is that it does not bounce. This is what goes through. Reflection is what bounces. So it will go through other mediums. A medium is a solid, a liquid, or a gas. Those are the 3 things that usually you're going to see light traveling through. And then, of course, it changes direction, just like reflection. So both reflection and diffraction change directions. How does diffraction work? So it strikes an object that causes the wavelength to bend at a different angle, kind of what you see here. Strikes it, then it bends at a different angle. Then that angle goes through, and then you get to see it through your eyes, whatever that angle and that changes. Your eyes then, of course, will see different colors based on the different angles. So when your eyes look at the different angles, that's how you get different colors. And the angles that bend is going to be red, orange, green, blue, yellow, indigo, violet. So that Roy G. Biv, you're going to have that same thing there. All right, other forms of diffraction are going to be one where you might see something that gets spread out because it's going through something. So you might have a surface that has a small opening, and you have an incident ray that's coming in. And then you have what's called no refraction. So the incidence of refraction here is what we represent by this little N. And in this case, there's none, which because it's going in a straight line, which is going to be the brightest. So because this gets the most that's going to go through here, you're going to have the brightest amount of light. As you go out and it starts to refract and spread out through the opening, now you're going to have an incidence of refraction of 1. And then you're going to have the same thing on the other side, because again, there's still the law of reflection that does occur, because you're always going to have equal distribution. So then you also have 2, and then you would also have 3. So these are showing you the different incidences that you have, which means you have different angles of incidence. When you have that, this is going to be the brightest, and 1 is going to be a little bit brighter, a little dimmer, and then 2 is very much dimmer, and then 3 is very, very dim. So as you move along and have more bending away from the light source, you're going to have more dimness, meaning that it's not going to be very bright, and you're going to have, because you're having a higher incidence of refraction, right? So the 3s and the 2 would be more dim, and then the 0 and the 1s would not be this dim, and they would actually be brighter. All right, let's talk about lenses. So lenses, this is a convex lens because it has actual openings that come towards you that bend out. So that concave would be the squishy one that squishes in. So if you have an image, that image's light goes through the lens, and then when it goes through the lens, it refracts. And then because it's going through 2 different parts of the, now there's a lot more rays. We're just showing you like the top and bottom from one point. So you have all of these rays though emitting from all angles, but we're just showing you kind of 2 points so you can understand it. And once this light goes through, it refracts at a certain point. This is what we call the focal point. The focal point will have this part from the base of where you have everything level to that point where everything crosses. That's going to be your image height. From this point of this, the lens to wherever the focal point is, this is what we call your image distance. This is your object height, meaning however big your object is, and then of course your object distance, which is the distance between the object and where it is from the lens. Then you also have these labels that show 2F. 2F shows you that you have double the focal point length, meaning that it's how the length between where the focal point is and where double is showing you with the value of that 2. Where F is what we call a real image. It's going to be inverted, meaning upside down, and it's going to be backwards. And that's how your eyes work. Your eyes are a convex lens. They see things that go through at a focal point, which is the back of your eyes, that is upside down and backwards. Your brain translates that and flips everything right side up and forward so that you can understand it. Okay. This is what we call the real image, and it is smaller. So C is the center point, right, between the focal point and then, of course, the double focal point, which means C, if you're a little bit below C, oh, did I not write these in? I thought I wrote these in. I don't know, but we'll get it. If you're a little bit below C, that means your image is going to end up being smaller. If you're further away from C, meaning that you're on this side, then that means your image is going to be bigger. I think I talk about that here a bit more. Your equations. So your equation is object distance plus image distance equals the focal length. This is how you can figure out any of the distances, or you can figure out the lengths that you need. So this is the equation. 1 over the object distance plus 1 over the image distance is equal to 1 over the focal point. So here's an example question. A 6 centimeter object is 15 centimeters from a convex lens. It has a focal length of 5 centimeters. What is the distance of the image from the lens to the nearest hundredth? All right. So first list out your variables. So you have object height, which is 6 centimeters, which is your DH, your object distance, which is 15 centimeters, which is your DO, and then you have the focal length, which was given to us as 5 centimeters. So you just take what you have and then you list them out. So now all we have to do, right, is just plug them in. So 1 over 15 plus 1 over x, because I'm looking for my image distance. And then 1 over 5, because that's what they want us to find, is what is the image distance. So now I have these. A very simple way to do this, you don't have to find a common denominator, just change everything to decimals. So 1 divided by 15 and 1 divided by 5, that gives you 0.067 and gives you 0.2. And then you're going to subtract 0.067 on both sides so that you can get rid of it on the left side here. And you'll be left with 1x is equal to your 0.2 minus your 0.067, and that means that you'll have 0.133. So 1 over x is equal to 0.133. When you do that, this goes away. I won't do that. So when you have this, what is it? When you have this 1 over x, anything that's the 1 over x that you have here, you want to go ahead and actually use your calculator to very simply figure out what that 1.33 is. So I'm going to show you real quick. So if you have the 0.133, so that's your answer, but it needs to equal x. All you can do is just hit this little button here, which is the 1 over x. Make sure you have it on scientific on your phone as well. Should have scientific. And then just hit 1 over x. And when you do that, that goes ahead and gives you the 1 over x of it. You don't have to start figuring out what everything is, okay? So nearest hundredth, that's the first number past the decimal point. So that's going to be 7.5, which is our answer here, which would be 7.5 centimeters. That's pretty much it. So just make sure that you plug it in because it's all fractions. Once you figure out what the fraction is, just go ahead and hit that 1 over x, and that'll give you your answer. Don't forget to hit the 1 over x. All right, so this is a concave mirror. How do you tell the difference between a concave mirror and a convex mirror, or a concave lens or convex lens? It's real simple. If you can walk into it like this, I can literally walk into it like a cave. That's right. I walk into it like a cave. If I can't walk into it, then it's the other one, which is convex. It's vexing. I'm vexed. I don't know. But a concave, right? So if I can walk into it, then like a cave, then it is concave. So here's this bear dog. I don't know what it is, but it's the best I could do. So if you have the image that has light that travels, we're doing it again, 1 point. Remember, there's light emitting in all directions from this bear, which travels in a straight line. So this light, though, would travel to this direction, hit the lens, and then, of course, it's going to reflect back. Same thing with this one's going to hit that and reflect back. When that occurs, that's kind of showing you that where we're looking at the center. So if I have my focal point here, where everything's going to hit, but my center is here, that means this is the location of where the actual size and image is going to be. So the further from the center to the left direction, so the more I move this out this way, the smaller the image is going to be. The further you move it away, the smaller the image is going to be. I don't know, just ignore that. The closer that you move it to the center, so past the center on the right side, that bigger that image is going to be. Also, the image here is going to be inverted the further away you move it. The closer you move it towards the mirror, it's not going to be inverted. It's actually going to be right side up. So that's what kind of mirrors sort of do. Oh, look, here you go. Okay, so smaller. So further this way, smaller the image and inverted. And then if I go to the right side of where the center is, then it's going to be bigger and not inverted. It's going to be right side up. On the center, of course, will be the actual size. So how do you figure out equations? Here's our equation, the object distance. This is for mirrors. So the object distance over the image distance is equal to the height of the object over the height of the image. So that's what all those are. So DO is object distance, DI is image distance, HO is height of the object, and HI is the image height. So here's an example equation. Question. If the bear is 8 centimeters at 40 centimeters distance from the surface, what is the image height if the focal length is 10 centimeters while the image is 16 centimeters in front? So let's look at our variables. We have the height of the object, which is our 8 centimeters, right? That tells us how high it is. We have the object distance, which is 40 centimeters. We have the focal length, which was given to us at 10 centimeters, and then the image distance was told that it was 16 centimeters. So we're going to plug everything in. So here's my object distance, which is 40, my image distance, which is 16, my height is 8. I don't need the focal length, so that's just a distractor. I don't even need that one that's there, and that'll end up giving you what you have for each of those. So then we're going to cross multiply. So we're going to do 16 times 8, and then we're going to divide that by what's left over, which is the 40, and that's going to give you your x. So you always can do that when you have two sides of fractions equal to each other. So 16 times 8, 128, divided by the remainder, which is 40. And that gives us 3.2. So that gives us 3.2 here. But here's the thing, is that in this section, because we know that this is 16 centimeters that's away from this image, which means that when we're looking at the focal point, which we're looking at 10 centimeters, that's why the focal point was given to you. So you're given at 10 centimeters for the focal point, which is here, and it's saying that the image is 16 centimeters, which means it's way further back. So if it's way further back, that means that the image is going to be smaller, which also means that it's going to be upside down and inverted. If that's the case, and you're looking at the smaller image anyways, because this is 8 centimeters, and then the image you get is 3.2, that must mean that it's inverted, which means you need to put a negative sign. If it was a bigger image, so let's say this was a greater than 8, then you would have a positive sign. But because it's a smaller image that's less than 8, that means you need to make sure that you put the negative to represent the image is actually inverted or flipped upside down. All right. Those are the big ones. Make sure you also know the spectrum. So Roy G. Biv, red, orange, green, yellow, blue, indigo, violet. Keep in mind that Roy, the red, is radio. So radio waves and things like that don't tend to put out a lot of energy. If you stand next to a radio, you're not going to die, right? Move across the spectrum and you go to things like gamma rays, which is like nuclear power plants, or chemotherapy radiation, things like that. Those things that you stand near are going to kill you, or they're killing things that are targeted. So that means that the stuff on the right side of the spectrum has a lot more energy than the stuff on the left side of the spectrum. So red, orange, and yellow tend to be very low in energy. As you move up in the blues and the indigo and violet, you have a lot more higher energy concentrations because your wavelengths are shorter. So make sure you review that and know your spectrum before you take the test, okay? So any notes that you have taken, any notes that you've taken from here, I would have gone through. If you haven't, go back through and write down some of these notes. You're able to use on your test. The test is timed, but you have plenty of time to take it. I think it's set up to be for like 2 hours. You must pass the review. So there is a review before you take the test. You got to pass the review before you can take the test, and I release it to you. you have to make a 70 or higher. If you pass the review and you made a 70 or higher and I haven't gone in and opened up the test, you need to send me a text message and I'll make sure to open it for you. Okay. I will be checking this on Tuesday and opening up tests to those who passed the review. Again, if you haven't heard back from me or you don't see that your test has been opened, please send a text message and then I can go ahead and open it for you. Or you can send a message on Google Classroom. So I will not be opening the test after 3 p.m. Okay, so after 3 o'clock, I'm not going to be sitting at my computer constantly putting out tests or answering your text messages randomly throughout the evening. So you need to make sure at 3 o'clock I'm done. After that, we'll be late and I'll release them the next day, but you will lose percentages off of that. So make sure you keep that in mind. If you would like additional help on reviewing any of the material that you just are struggling with and can't understand, please go ahead and text me at that number, which is 912-497-5126. We can schedule a meeting. If there's more than one of you, we'll schedule a meeting with a few of you in order to kind of go over some of the information if you need to, or it might just be you. All right, so if you want additional help or any information, especially if you've gone through the review and you're struggling through the review, then definitely consider texting me and I'm available all from 9 to 3, okay? After 3, I'm not available, all right? If you fail the test, though, you do get one opportunity to do a retake. Just keep in mind that they're not the same questions. Some might be, but it pulls everything from a large test bank. So just don't think that you can fail the test and know the questions and go back and retake it. So they are going to be different. So make sure that you study. But if you do fail it, you are allowed to go back and take it one more time. In order to do that, after that, it's done. Okay. Yeah, I think that's pretty much it. All right. So let me know if you have any questions, and I will do reviews for those of you who want it in a live session meetings or anything like that. Okay. Good luck, guys. Keep up the good work. A lot of you doing really well, and I will see you next time.